Okay, so patterns. So there's a first section in the book, but I'm going to skip it because it just talks about general patterns. So the patterns we deal with are arithmetic. Arithmetic means linear. So it's where you're adding or taking away a common difference. Okay, so you're adding or subtracting something. So there's a formula in your logbooks for the general term, or Tn, or nth term of a arithmetic sequence. So it's Tn equals a, where a is your first term, plus n minus 1 times d, where d is your common difference. N stands for the term number. So if you wanted term 1, you put in 1 for n, and so on. So the easiest thing is just to do some examples in it. So find the nth term, Tn, of the arithmetic sequence, minus 2, 3, 8, 13. So the first thing we need to do is figure out our difference. So what am I doing between 2 and, it's told us it's arithmetic, so it's adding or subtracting. How do I get from minus 2 to 3? I add 5. Check the second one to make sure that it's still adding 5, and it is. So then you can pull out your a, which is minus 2, your d, which is 5. Write down the formula. So Tn is equal to minus 2 plus n minus 1 times 5. Now that means that's all multiplied by 5, so what we do is we multiply it out. 5 by n is 5n, and 5 by minus 1 is minus 5, and tidy up your numbers. So minus 2 and minus 5 is minus 7, so 5n minus 7.
Is that formula?
Yeah. Okay, and it says hence find T20, T21, and then T21 minus T20. So T20, you're just putting in 20 for n. So T20 is 113. T21, you're putting in 21. And 98. I think I've done something wrong with 20 in there. That's 93, sorry. Okay, so then T21 minus T20. What do you think that's going to be? So T21 minus T20 are just two terms that are one apart, so what will the answer be? The difference, exactly. Okay. You frozen, Chris? You could close one or two of the windows if there's a drop coming right in on you. Okay. So the next example then, find the number of terms in the sequence. So some sequences or series, some sequences go on forever, and sometimes we have an end. Okay. In this one we have an end, but we don't know anything about the sequence. So the easiest thing is to find out the Tn, and then let it equal to this, and find out the n that gives that, because that's what we want. We want to know how many terms are in the sequence. So we're going to do the same as we did a minute ago. How do I get to minus 3 from 1? I'm taking away 4. Check that it's right. So then A is equal to 1, D is equal to minus 4. And get your Tn. And multiply out. So 1 minus 4n plus 4. So Tn is equal to 5 minus 4n. Okay, so now the last term. So, and we want to know what term number is it. So we're going to let Tn be minus 251 and find out what n is. So minus 251 minus 5 equals minus 4n. So minus 256 is equal to minus 4n. So n is equal to minus 256 over minus 4. So n is equal to 64. So what that's saying is that the 64th term gives a value of minus 251. Okay? We happy? Okay, so that's arithmetic again, more arithmetic stuff. So again, arithmetic just means that it's going up or down in a constant number. Oh, that's what I've done. Okay. So in an arithmetic sequence, T4 is 6. 3 times T2 is equal to T10. Find the value of A and D and hence write out the first 6 terms of the sequence. Okay, so when we're doing something like this, we're going to use the formula and fill in what we know. Okay, so Tn is equal to A plus n minus 1 times D. So the first bit of information we know is that T4 is equal to 6. Okay, so this is 6 and n is 4. We don't know A and D. Alright, so 6 is equal to A plus 4 minus 1 times D. So 6 is equal to A plus 3D. Okay. And then over this side, 3T2 is equal to T10. Now, we're going to fill in 2 into this, and we're going to fill in 10 into this. So it's going to be 3 bracket A plus 2 minus 1 times D will be equal to A plus 10 minus 1 times D. So I'm using the formula at both sides. So then we can tidy this up before we multiply in. So 3A plus 3D equals A plus 9D. Bring everything to one side. So 2A minus 6D is equal to 0. And here we end up with 2 equations with 2 unknowns, so your simultaneous equations. So I'm going to bring this one down and multiply it by 2. So 2A plus 6D equals 12. So 4A equals 12. A equals 3. And then you put it back into either one to find out D. 3 plus 3D equals 6. So 3D equals 3. That's what I'm doing. So D equals 1. So find A and D and hence write out the first 6 terms. So the first term is 3 and D is 1 and it's a plus 1, so I'm adding 1. So 3, 4, 5, 6, 7 and 8. Is the red hard to read? I don't know why I started writing in red. Is it okay? Will it be better in black? No. So arithmetic just means I'm adding or subtracting something. I have my formula from my logbooks to get the general form, and that's all I can really use. So I didn't. I brought this one over and multiplied by 2. Alright, so the two things in circles are my simultaneous equations. I'm going to put them together. Okay. Everyone good? Okay. So if p plus 2, 2p plus 3 and 5p minus 2 are consecutive terms of an arithmetic sequence, find the value of p. So what we know about an arithmetic sequence, it's going up in constant, so the difference between this term and this term will be the same as the difference between this term and this term. So remember, if we had the sequence with numbers, we could take the first one from the second one to get d, or we could take the second one from the third one to get d. So that's what we're going to do. So 2p plus 3 minus p plus 2 would give me d, and 5p minus 2 take away 2p plus 3 would also give me d, and they'll be the same, and then I can get an equation and solve it. So 2p plus 3 minus p minus 2 equals 5p minus 2 minus 2p minus 3. P's to one side, numbers to the other. So 4 takes 6 is minus 2. 3, 8, 6. So p is 3. So find the value of p. If we wanted to find those terms, the first one is p plus 2, then 2p plus 3, and then 5p minus 2. We could just fill in the values, so this becomes 5. 6 plus 3 is 9, and 15 minus 2 is 13. So in an arithmetic sequence, if I take this one from this one, I'll get d, and if I take this one from this one, I'll get d. So that's what I did, okay, because d is the same for both of them, so I can let both sides equal. Okay. So we have two different questions here. Now, I'll show you the way they kind of want this done, but then I'll show you a really easier way, and there's nothing wrong with doing the second way. So, given that Tn is equal to n plus 1 over 2, determine if the sequence is arithmetic or not, and the sequence is increasing or decreasing. So what they want you to do is do it in terms of n's. So Tn, the difference between Tn and Tn plus 1 would be d. Do you see what I'm saying? Okay, so instead of n, we're going to put in n plus 1. So n plus 1 over 2 minus n plus 1 over 2. They have a common denominator, so I can write it as 1. And this is n plus 2 minus n minus 1. Be careful now, the minus goes into both of them. The n's are gone, and you end up with a half. A half is a constant, therefore it's arithmetic. There's nothing to stop you from saying, okay, what's T1? 1 plus 1 over 2, so that's 1. T2, 2 plus 1 over 2, so that's 1.5. T3, 3 plus 1 over 2, so that's 2. And T4, 4 plus 1 over 2, so that's 2.5. And saying the difference between them all is a half. Okay?
Miss, what would it be if it wasn't equal to a constant? Like, what could your answer be?
So you might be multiplying, you might be to a power, so exponential or geometric.
But like, would your answer still not be coming out as a number?
Not if you take them away, because for a geometric it's dividing.
Okay.
Alright? So remember, in a geometric you're multiplying each term to get the next term.
Yeah.
And it's either multiplying by a whole number or multiplying by a fraction.
Okay.
Okay. So arithmetic is the only one where you're adding or subtracting. Okay, is it increasing or decreasing? Increasing, because this is a plus. Okay, I'm going to do the other one both ways again. So Tn plus 1 minus Tn. Okay, here it's a little bit more work because we need to get a common denominator. Okay, so that becomes 2 times n plus 1, 2 times n plus 2. So we have 2n plus 2 minus 2n minus 4 all over n plus 2, n plus 1. And that becomes minus 2 over n plus 2, n plus 1. This is not a constant, therefore not arithmetic. Okay, and it's a minus. N is always positive because n is your term number. So this will be positive, but this will always make it minus. So this one's decreasing. Sorry, yeah. So again, if we did this with numbers, if we just filled in T1, we'd get 1. T2, we get 2 over 3. T3, we get 2 over 4. T4, we get 2 over 5. Sorry, that's 2 over 2. Yeah, 2 over 2 as well. Yeah. Okay, so you can see that it's not arithmetic. This one?
Yeah.
So I'm doing n plus 1 into this. So 2 over n plus 1 is 2 over n plus 2. And then I'm doing Tn, which is just itself. Because If it's arithmetic, that minus that will be d, which will be a number, a constant.
Would you not have n plus 1 over 2 for tn though?
We're doing the second one. This is part 1, which I did down here, and this is part 2. Is that okay?
Yeah.
We all good? Okay, then we have another formula to do with arithmetic, and it's just the sum of an arithmetic sequence. Again, it's in your logbooks, alright? And the letters are the same. A is your first term, D is your common difference, and N is your term number. So, this is for, series as opposed to sequence, but it doesn't really matter. A series is when they put pluses between them, okay? It doesn't have to be a series, it can be a sequence, it can just be commas. But it is when you have an end value, or else it's when you want to find out the sum of the first 10 terms or the first 20 terms, whatever it may be. So find the sum of the series. It's the exact same. We find out our difference. So A is 4, D is 7, and then it's just filling into your formula. Now, we don't know how many terms there are, so we need to do Tn, let it equal to 144 to find out what term that is, and then fill it into Sn. Okay, so we need n. So we're going to go over here and do Tn, and let Tn be 144, A is 4, we're looking for n, and D is 7. So 144 is equal to 4 plus 7n minus 7. 144 minus 4 plus 7 equals 7n. Okay, so there's 21 terms. Okay, so then we're going S21 is equal to 21 over 2 times A plus 21 minus 1 times 7. So you can put all that into your calculator in one go. Just be careful with all your brackets. Okay. Make sure to try it with an example where you have the answer in front of you, so that you know. I'd probably, putting them in the calculator, put these into brackets as 2 by 4 and put these in brackets as 20 by 7, just to be sure. Okay, so the sum of 21 terms up to 144 is 1554, and that just means that I'm adding 4 to 11 to 18 to 25 and all the way up. Alright, that's all it's saying. Does that make sense? Okay. Sometimes they'll give you Sn, so given Sn is n squared minus 4, and find an expression for Tn, and hence determine that the sequence is arithmetic. Okay, so when you get something like this, so the first, if I sum only the first term, it is the first term, isn't it? Because the sum of the first term is just itself. So T1 is minus 3. If I sum the first two terms, I find the first term plus the second term, and if I have the first term, I can take that away and then get the second term. Does that make sense to everybody? T1 is the same as S1, yeah. And then T2 will be S1, will be T1 plus T2, so I'll just take away T1 to get T2. Because S2 means sum of the first two terms. Yeah? So I'm going to put in 2 squared minus 8 is 4, is it? No, it's minus 4. Okay. So if S2 is the sum of the first two terms, if I take minus 3 away from minus 4, no, minus 4 minus 3. Okay. So the sum of the first term is minus 3, which is just the first term. And then if I sum the second two terms, I get minus 4. So it's, what did I add on to minus 3? It was just minus 1, so that's term 2. It says determine if the sequence is arithmetic, so we can't just stop there. We'll have to go for another one. Because just because the first, we need to check that the difference is constant between them all. So 9 minus 12 is minus 3. Okay, so my terms are minus 3, minus 1, 1. So what's happening between here and here? I'm adding 2. What's happening between here and here? I'm adding 2. So it is arithmetic. Because S2 means the sum of the first two terms. Okay, and S3 means the sum of the first three terms. So S1 is just the first term, but then when I get S2, I need to take away the first term, and when I get S3, I need to take away the first two terms. So when I do S3 minus S2, that leaves me with T3. Okay. We're nearly done with arithmetic now. Yep. Okay, the last thing then is the sigma notation. Remember this? So we use it sometimes in formulas for the sum of. So sometimes you might be given, use sigma notation to represent 2 plus 6 plus 10 plus 14 for 45 terms. So we need to write it in terms of Tn, but then just use the sigma notation to say that it's just for 45 terms. So my difference is 4, so A is 2, D is 4. Tn is, sorry, a plus n minus 1 times d. So Tn is equal to 2 plus n minus 1 times 4. Uh, 4n minus 2. So sigma notation, all it is that you're writing down, okay, I'm going to go from n equal to 1 to 45 of 4n minus 2. It's just to be able to represent what that means, like to understand what that means. Okay, so what that means is that I'd put in n for 1, and this means sum, and then I'd add it to n with 2, and I'd add it to n with 3, all the way up to n with 45. Does that make sense to everybody? So this symbol means sum of. Okay? So when we're given this, it means the sum of this when I fill in n as 1 all the way up to 45. So I fill in 1, get an answer, then fill in 2, get an answer, then fill in 3, get an answer, fill in 4, get an answer, all the way up to 45, and I add them all together because this means sum. Okay? We don't really do this because doing it 40, it's just a way of writing it. So if we got a question like this, we'd convert it to a SN formula and then use that because it's easier. And we're going to do that in the next example, because we don't want to do this 18 times. So in the next example, we're given the sigma notation and we're asked to find the value of if you did it out. What we do have to do is we do have to do a few to get our A and our D to be able to use the SN formula. So when R is 1, 4 times 1 minus 1 is 3. When R is 2, 4 times 2 minus 1 is 7. When R is 3, 4 times 3 minus 1 is 11. So do 3 terms just to make sure your difference is the same between them all. So it's arithmetic. My A is 3 and my D is 4. So then I can just use SN. Okay, so we're looking at 18. So S18 is equal to 18 over 2 times 3 plus 18 minus 1 times 4. And then just enter your calculator. So 666. So the sum of the 18 terms is 666. Okay, so then the other thing we have is geometric sequences. Again, the formulas in your logbooks, we have a Tn and an Sn for that as well. So Tn is your general term, Sn is your sum. We've been using the sum in financial maths a bit recently. So find Tn and T10 of the geometric sequence. So for geometric, they're being multiplied. Okay, so this is being multiplied by something to get that. So how do we do it? We do 1/4 divided by 1, or 1/16 divided by 1/4. So you divide the second term by the first term, or the third term by the second term. And the answer is 1/4. Okay, so geometric, r is equal to 1/4. A again is your first term. So Tn is equal to a times r to the power of n minus 1. Tn is equal to 1/4 to the power of n minus 1. So the 1 really is no use there, so we'll just leave it as 1/4 to the power of n minus 1. And then find T10. Okay. So if your r is a fraction, your numbers are going to get smaller and smaller and smaller and smaller and smaller. Okay? Because the number under the line will be getting bigger. If your r is a whole number, then they'd be getting bigger. So is that okay? Okay. Okay. So geometric means it's being multiplied by something. Arithmetic means it's adding or subtracting. So to find r, you're dividing T2 by T1 or T3 by T2. Okay? I just wrote down r equals T2 over T1 or T3 over T2. So if it tells you it's geometric or if it tells you it's arithmetic, you don't need to check a few of them. But sometimes it won't tell you, so it is good practice to check a few of them. Because you should be getting the same answers no matter which two you pick. Okay. Do we need to go back? Everyone okay? Here you are, right?
Yeah.
Okay, so here in a geometric sequence, T3 is 32 and T6 is 4. Find A and R and hence write down the first 6 terms of the sequence. Okay, so here we're going to write down our formula and we're going to fill in what we know. Okay, so T3 is 32, so 32 is equal to AR3 minus 1, so 32 is equal to AR squared. T6 is equal, so let me just write what I'm using. And over here, T6 is equal to 4. So 4 is equal to AR to the power of 4 minus 1. 4 is equal to AR cubed. Yep. Thanks. Okay, so although these aren't beside each other, we have r to the power 2 and we have r to the power 5. So we can, if we divide this one by this one, we'll end up with r to the power of 3, and we can cube root it to find out what 1r is. Alright? So we're going to put AR5 over AR2, and the answers over each other. So 4 over 32. So this will be gone. 2 of these will be gone with 2 of those. So r cubed then is equal to, what does 4 over 32 simplify to be? 1/8. So then r will be equal to the cubed root of 1/8, which is a half. Okay. So we found r, we need to find a. So you can just put it back into one of them. $128. And then it's to find the first 6 terms. So 128 multiplied by a half. Pardon? So multiplying by a half is the same as dividing by 2. Okay. Why did we divide these? So this is the 3rd term and this is the 6th term, and this is multiplied by an r and an r and an r to get as far as here. We have no other information, so if we put this over this, we'll get r cubed and we'll be able to find out r. Okay, so we know that it's multiplying, so if we divide to try and narrow it down. So we put this side over each other and the answers over each other. Okay, so again we talked about this, but just to note it, the ratio r is T2 over T1, or T2 over, sorry, what did I just say there? T2 T2 over T1, or T3 over T2, or T4 over T3, etc. for a geometric. So when we have a geometric that has unknowns in it, all we're going to use is that fact that if I put the 3rd term over the 2nd term, it will be equal to the 2nd term over the 1st term. So 3x and x plus 6 are the first 3 terms of a geometric sequence of positive terms. Find the value of x and then find the 10th term of the sequence. Okay. So it's geometric. So x over 3 will be equal to x plus 6 over x, and then cross multiply. So x by x will be equal to 3 times x plus 6. So x squared equals 3x plus 18. We have a quadratic, which is fine. We'll end up with 2 values of x. 18, 6 and 3. No. Yes. Minus and plus. X is equal to minus 3 and x is equal to 6. Now it's said positive terms, so it can't be the minus 3, so x is 6. So the sequence becomes, so 3x, x plus 6, so 3, 9, 15. And then it wanted us to get, what did it want us to get? The 10th term. So then we're just going to do Tn. So I'm multiplying, oh, that's 12. What am I doing? Oh, sorry, I'm filling this in wrong. I'm going too far. So 3, 6, and then 9. Yeah. So I'm multiplying by 3. Okay. So Tn, my A is 3, my R is 3. So Tn is equal to 3 brackets 3n minus 1. So Tn is equal to, so we're looking for T10. 3 bracket 3 times to the power of 9. Oh my god, I don't know what I'm doing. Sorry. Yeah, it's 18, isn't it? 6 and 6 is 12. What am I doing wrong here? There's something wrong. So 6, and then 6 plus 6 is 12. But that's not giving me a common ratio. What am I doing wrong? Six. That would be 2, wouldn't it? Good God. I left my brain at home. Sorry. Okay, R is 2. Okay. So 3 brackets 2 to the power of 9. 1, 5, 3, 6. You got it? All right. Will we take a little break?
Yeah.